don't have the luxury of time to waste. And so I've started the recording, so people who are not in class will be able to have access to that and catch up with the class. So welcome to class once again, and I want to quickly tell us that obviously the growth mindset still remains very important, knowing that things will be changing and is required of us to also ensure that we evolve. So let's just go straight to today's class. Fundamentals of networking. We have done some practical labs where we configured DHCP, configured DNS, and it's important we understand how all of these things works. When it comes to the matter of internet, there are some people that are employed just for IP addressing. We call them IP engineers. All they do is subnet, assign IP to a network. As we progress in this class, we will continue to understand more. Understanding classful and classless IP subnetting. Understanding classful and classless IP subnetting, part 1. So basically today we're going to be looking at the classful. So fundamental understanding of subnetting in IP networks. Fundamental understanding of subnetting in IP networks. We've already understand what a network is. We said is the connection of two or more computers, devices for the purpose of sharing resources. And we also spoke about the need for an IP address to be allocated to devices on the network in order to be able to communicate. So if I am going to print a document, for instance, on a LAN network, I need to have the IP address of the printer. My system needs to understand how to talk to that printer. My system must be on the same network with that printer. That is when I can successfully print a document. That is when I can successfully maybe scan a document to a scanner. Okay, so this is how things really works. So what is subnetting? We said subnetting is a technique used in IP networking to divide a larger network into smaller, more manageable subnetworks or subnets. Subnetting is a technique used in IP networking to divide a larger network into smaller, more manageable subnetworks or subnets. So when you hear the word subnetworks, it is abbreviated to subnet. Every IP address must have a subnet mask. Every IP address must have a subnet mask. Now, what are we saying here? You will remember that anytime we power up our PC in packet tracer and you assign an IP, automatically a subnet mask appears. Give me a moment. I want to power up my packet tracer and show us something. Now, I'm going to stop sharing.
Okay.
Are you with me?
Yes, I'm with you. I'm with you, sir.
Okay. So, please, if you can see my packet tracer now, you let me know. Can you see the packet tracer?
It's not on here yet, sir.
Okay. Can we see it now?
Not yet. It's just showing Mr. Mario Kung presenting. It's all black.
Okay.
Okay. Yeah.
And I can see it. I log in with two different systems, so I can see it on my phone.
Yes. Probably my own network is slow in response.
Yeah, I get. Okay.
I need me to log in and log out and log in. So
Yeah.
probably I can
Yeah,
give you
maybe you do
comment.
that. Yes. Okay, so
All right.
Madam Genevieve, how are you doing, ma'am?
It's showing now.
It's showing now, right? Okay, thank you. So,
So it's showing now.
okay, thank you. All right. Mali, can you see it now?
Yes, I can see it now. It's not
Okay.
showing. I'm back on.
Okay, so this is my PC, and I am trying to assign an IP to this PC. Remember, we are discussing IP networks. I want to understand something about subnetting. So if I put 192, for instance, 168.20.5, once I click on the subnet mask, automatically it brings up the subnet mask, even when I do not assign any subnet mask on it. So for every IP that we have assigned to a device, there must be a subnet mask. I'm going to explain that in a GPU. Now, for instance, if you call me and you say you are coming to my house, what I will tell you is if I just give you my house number, if I give you my house number, the question will be, where is my house? That will be the next thing. Where is my house? I just give you a number 14. On the island, there are different number 14. There is need to have a street. So that is where subnetting comes in this matter. Okay, just give me a moment. So I just wanted to quickly explain that to us.
Okay.
So I'm sharing my screen again on the slide that we are. So yes, it's not visible. I want to try to share. So please confirm it's visible now. I'm sharing the slide that I already shared earlier in the day. So we are looking at understanding classful and classless IP subnetting. This is the foundation of networking. And I said some people are employed primarily for subnetting. They are employed primarily only for subnetting, nothing else. IP addressing. They call them IP network engineer.
Just for submitting.
Yes. Can we all see my screen
Okay.
now, please?
Yeah, we can see it.
Okay, good. Thank you. So, and we said subnetting is a technique used in IP networking to divide a larger network into smaller, more manageable subnetworks. So when we build a company, for instance, when we build an estate, we put street in the estate, we put number. So you see some estate, they say R2 unit 10, R2 unit 8, R3 unit this. So those units are for them to be able to recognize those different buildings. You see some estates, the whole buildings are the same in structure, in everything. So the only means through which you can use to identify them is through those units. So IP addressing and subnet mask is used for the identification of devices on a network. This improves network performance and security and helps efficiently utilize IP address space. You will keep understand some things as we proceed. The whole internet started small, but eventually grow and still growing today. The means through which any system or device communicates on the internet is via IP address. We all understand this. Since it is necessary for all IP
Yes.
addresses on the internet network to be unique. Now, IP address has to be unique. Everybody cannot be bearing the same name. It's going to, so if for instance, oh, it's my namesake, it's your namesake, but it can't be the same surname with you. If it's the same surname with you, there will be something different about you people. So you say, you can't meet a man that is the same thing as, the same surname like you, the same, so that is why there is need for us not to misplace things or misuse things. We need to ensure that there is a unique identification of each of the devices on an infrastructure. So a system had to be created for dividing up the available addresses and share them among all organizations. So there is a central authority that carries out this IP address allocation. For instance, we have people that we call Afrinic. Afrinic are the one that assign public IP addresses to companies, to ISPs that needs those IP addresses. So, basic concept of IP addressing. Please, I want us to pay attention to this part. This is the most important part of our study, because once you understand this part, it becomes easy for us as we continue to progress in our training. The basic concept of IP addressing, we have what we call IPv4 address, right? And I know some of us, we already understand that we have IPv4 and we have IPv6. Now, what is IPv4? We say IPv4 consists of 32 bits that is typically written as 4 decimal number separated by periods. So 32 bits. In other words, this first 192 is actually 8 bits. 168 is another 8 bits. 20 is also 8 bits. 1 is also 8 bits. When we add all of these 8 bits together, that's in 4 places, that's what makes the 32 bits. Do we understand this? I could remember,
Yes, sir.
I could remember I shared with us then that the 8 bit is written in 10101001, just something like that in 8 places. So this 192 is actually in this format because this is the format the computer can understand, 0 and 1. So 192 is 8 bits, but this is the one that is easily recognizable by man. Okay, so that is how we come to where we have 8 bits here. So that's how IPv4 is formed. Our concentration is going to be on IPv4. But then you could go for an interview and they could ask you, we have 2 major types of IP addresses, IPv what? IPv4 and IPv6. They could go further and say, okay, what is the major difference? IPv4 consists of 32 bits, while IPv6 consists of 128 bits that are written as 8 groups of 4 hexadecimal. Hexadecimal is base 16. Hexadecimal digits separated by columns. IPv4 is separated by periods. IPv6 is separated by columns. So, for instance, if you are asked to differentiate between IPv4 and IPv6, our focus in this class is IPv4. So let's move on now. For every IP address that you see, it actually consists of 2 portions. I repeat, for every IP address that we see, it consists of two portions: the network portion and the host portion. The network portion and the host portion. Now, I will explain that. The network and the host portion is determined by the subnet mask. So, we said the network portion identify the specific network. Now, anytime you are talking about the network portion, you are talking about the street. The street where that house is located. The house is the host portion. The street is the network portion. That is the best way to explain this now. So we can have two streets bearing the same name, but the houses number will be different. Or you could have two houses having the same number, but they cannot be in the same street. Once you have a street, numbers will be different. Want to enter maybe Sadiku Street, number 1, number 2, number 3. Now, once you have two number 3, that means there is an error. You can't have two number 3 in a street. That means people will begin to enter another person's house to go and do illegal activities, and nobody will be able to identify who and where that is coming from. So, the network portion is what identifies the specific network that IP address belongs to, while the host portion identifies the specific device or host within that network, the actual house number in that street. Don't worry, we will understand as we progress. Now, subnet mask. A subnet mask is a 32-bit number that makes up an IP address and divides the IP address into network and host portion. A subnet mask is a 32-bit number, a 32-bit number that makes an IP address and divides the IP address into network and host portions. For instance, or for example, a subnet mask of 255. Can we see my screen, please? Hello? Yeah. Can we see my screen?
Yeah, yes. But what I'm seeing is just network and host portions.
Okay. Okay. I will stop sharing and share again. So because I'm already on subnet max. Just give it a moment. See my screen now.
Yes, sir.
All right. What can you see? Hello? Can you hear me? Can you see my screen? What can you see?
Yes, we can see. I can see your screen.
Subnet
And
max?
what is here is subnet max.
Fantastic. So we need to understand what
Same here.
is what a subnet max really means. So understanding what a subnet max really means is going to help us in our quest for understanding IP addressing. Just give me a moment. So we say a subnet mask is a 32-bit number that marks an IP addresses and divides the IP address into network and host portion. Now look at this. For example, a subnet mask of 255.255.255.0. Anytime you see this kind of subnet mask 255.255.0 is called /24. Please, you have to put it in mind. 255.255.255. When you see 3 255s, is called /24. That's the short form in CIDR notation. CIDR, we call it CIDR or CIDR notation. The word CIDR is from the word classless inter-domain routing. We will get there. So, what does this mean? This first 255, second 255, and the third 255 is the network portion, while the 0 is the host portion. Remember, every IP address is divided into a network and a host portion. Every IP address is divided into a network and a host portion. So, in other words, now that we are seeing this subnet mask 255.255.255.0, the first three closed part is the network 255.255.255. That is our network portion. Why this 0.0 is the host portion, which means the first 24 bits. This first 24 bits, remember this 255 is 8 bits. The first 255 is 8 bits. The second 255 is 8 bits. 8 plus 8, 16. Then the third 255 is another 8 plus 16, making 24 bits. Are the network part, and the remaining 8 bits, this dot 0 is another 8 bits, are for host. For example, 192.168.100.0/24 means 192.168.100 is the network portion and .0 is the host portion. Do we understand this?
Yes, sir.
Okay, I'm going to explain something shortly. So, once you see the subnet mask, I want to duplicate this and then clean it, and so that you will get what I am explaining now. Just give me a moment. Can you see my screen, please? Can you see my screen?
Yes, sir.
Okay, I have a blank screen, just subnet mask, right?
Yes, sir. I can see your screen.
Okay, I actually wanted to explain something to us, and from the explanation, we'll be able to get something right there. So, when I have 255.255.255.0, the first 255, the first three 255s, which is the 24 bits, is the network. Now, imagine if I have 255.255.0.0. What happens? What will be the network and what will be the host?
The network is the 255.255.0. Why the last zero is the host?
Okay. Now, that is incorrect. Okay? That is not correct. Your network is those places that has 255.
So does this imply? Hello, sir. Sorry.
Please ask your question.
Does it does this imply that the network part cannot be zero?
Yes, the network part cannot be zero for a class full network, for a classful IP addressing.
Okay.
Do we understand this? So let me explain something.
Yes, sir.
Yes, sir.
So we have what we call class A, okay? Class A. We have class B, right? You remember that? You've read that. We have class C,
Yes, yes, yeah. I just remembered.
we have class D, and we have class E. Now, class A has a subnet mask of 255.0.0.0.
Zero, yeah.
So what is the network portion of this class A now?
The network of this class A is 255. The
And
host
the
is 0.0.0.
fantastic, thank you. That once you understand this part, you've understand classful subnetting. Now, class B is 255.255.0.0. So the network here is 255.255 and the host is 0.0. And class C is 255.255.255.0. Okay, so we move forward so that we can close soon. Now, the developers of
Actually
IP.
ready.
Somebody have a question?
No, 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 sir.
Okay. The developers of IP recognize that organization comes in different sizes, which is true, and would therefore need varying numbers of IP addresses on the internet. They devised a system whereby the IP address space would be divided into classes: class A, B, C, D, and E. Now, when they were designing these IP addresses, they designed these classes so that it can meet for small companies, for medium companies, and for very large companies, each of which contained a portion of the total addresses and were dedicated to specific uses. Some will be devoted to large networks on the internet and others for smaller organizations, while others reserved for special purposes. Okay. Since this was the original system, it had no name. It is called the IP addressing system. Today, in reference to its use of classes, it is called the classful. We call it classful. That class A, B, C, D, E. It's called classful addressing scheme to differentiate it from the newer classless scheme. The reason for this class is actually the classless, but you cannot understand the classless except you have understood what the classful really is. So, note, classful isn't really a word, but it's what everyone uses. Okay? IP address classes. There are 5 classes in the classful IP address system, which are given letter A through E. The table on the next slide provides some general information about the classes, their intended use, and other general characteristics about them. So we move to the next slide. On this next slide, so we're going to look at it now. IP address. Class A, we can see the subnet mask here. 255.0.0.0. Fraction of the total IP space. The total IP space in the world. Let me show you the pie chart. Look at this pie chart. Can you see it?
Yes.
Can you see the whole, if the whole IP address in the world is 100,
Yes.
class
In the
A
slide.
alone takes 50%.
It is the half of the
Half.
entire class.
Exactly. So that's why you see it here. Fraction of total IP space 1/2. Number of network bits 8. That is why we have it as 255.0.0.0. The network bit, the network ID bit, that's the network portion. So when you are seeing this table, you must be able to explain what the table really means. It's not just seeing the table, it's understanding what is written in the table. And then number of host ID, that's the number of host portion. That's this 0.0.0. Remember that this 0 here is 8 bits. This second 0 is another 8 bits. This third 0 is another 8 bits. So the three added together, 8 times 3, is how we get this 24. And what is the intention or the reason for having a class A? It provides unicast addressing for very large organizations with hundreds of thousands or millions of hosts to connect to the internet. So when you have a network whereby you have thousands of users that want to connect on that network, you will use a class A subnet. Then we go to class B. We can see the subnet mask as 255.255.0.0, and the fraction
So
of total IP is 1/4. Let's look at our pie chart again. So we see that class A is half, and if you look at class B, if we divide the whole thing into 4, class B will take one portion. So that is why we have it as 1/4. And number of network ID bits 16. How do we get this 16 here? 255, 8 bits. The second 255, another 8 bits, make it 16 bits. And number of host ID bits is this 200 here, 8 bits each, makes it 16. Unique addressing for medium to large organization with many hundreds of thousands of hosts to connect to the internet. Then the next is class C. Class C now, we have a subnet mask of 255.255.0. Now it is 1/8. So 1/8, let's look at our pie chart again. This is class C. If we take a quarter and divide it into 2, class C is going to be 1/2 of the quarter. So that is how we get it to be 1/8 here. In other words, if we divide it into 8 places, one portion of it is a class C subnet. So that's how we don't need to climb all of these things. We just need to understand that part of the subnet mask is the most important part. And then what is your network and your host ID. And this one is unicast addressing for smaller organization with no more than 250 hosts, that is 250 users to connect to the internet.
internet.
Yeah. So majorly we are going to be working with class A, B, C. Class D and E. Class D is for IP multicasting. You don't have to worry for now. Class E is reserved for experimental use. We've looked at this. So let's move to the next thing. Looking at this table and the pie chart, we can see that the first three, class A, B, C, comprise most of the total address space, about 87.5% of it. So that is A, B, C. That is why our focus is mainly on class A, B, and C. These are the classes used for unicast IP addressing, which means for message sent to a single network interface. That is what unicast means. To send a message to a single network interface. Unicast. The blocks also include associated broadcast address for these networks. I will explain what that one means. This is what we usually consider normal IP addressing. We think of class ABC as the papa bear, mama bear, and baby bear of traditional IP addressing, just like mother, father, and baby of traditional IP addressing. They allow the internet to provide addressing for a small number or very large networks, a moderate number of medium-sized organizations, and a large number of smaller companies. This approximately reflects the distribution of organization sizes approximately in the real world, though the large gulf in the maximum number of hosts allowed for each address class leads to inflexibility and problem. There is nothing much to understand here, just that we should understand what class A, how class A works, and that it is used for a very large companies. Class B is for medium companies, and class C is for smaller companies that is not more than 250 users. As we see, the classes differ in the place where the dividing line is drawn. Okay, we'll look at that between the network ID and the host ID portion of the addresses they contain. So that's what I was explaining. That's what I explained here. A is different from class B by the 255. A only has just one 255. B has two 255. C has three 255. That is how they are different from one another. So it's drawn between the network ID and the host ID portion of the addresses they contain. However, in each case, the division is made on octet boundaries. Octet boundaries. That 255 is an octet, 8 bits. 8 bits makes one octet. So, in classful addressing, the division does not occur within an octet. In classful, the division does not occur within an octet. Now, what we are saying is in classful, you cannot remove from this part or this part. You can't. But in classless, you can. That is where proper subnetting comes in. You will now take it to the 123 11000 and remove another 0 and begin to subnet. But in classful, you can't do that within an octet. Your subnetting is once class A does not work for you, you move to class B. You can't subnet class A into another class or another subnet. No. Okay. Minutes. Right. Okay, fine. The division does not occur within an octet. This is the major difference between a classful and classless IP addressing. Let's understand classful IP addressing first. Then we can fully investigate classless, where subnetting comes in. Classes D and E are special to the point where many people don't even realize they exist. Class D is used for IP multicasting, while Class E was reserved for experimental use. I've explained this. Class A, this. Class B, this. Class C, that. IP classful addressing network and host identification and IP address ranges. The classful IP addressing scheme divides the total IP address space into 5 classes, A through E. We've looked at all of this. One of the benefits of the relatively simple classful scheme is that information about the classes is encoded directly into the IP address. Is encoded directly into the IP address. This means we can determine in advance which address range belong to each class. It also means the opposite is possible. We can identify which class is associated with any address by examining just few bits of the address. This later benefit was one of the main motivators for the initial creation of the classful system, as we saw in the earlier lesson. I'm going to explain that now. So look at this diagram. The first bit is 0. It means it's a class A address. But if it is 1, move down to the next. So let me bring. So let's say 192 now dot 168 dot, or let me use 10 dot 20 dot 5 dot 1. So we need to convert it to binary. So let's assume that our 10 we are assuming now is 0100101 or 0. So if the first bit is 0, is class A. So that means this IP is most likely to be class A. But if it is 1, we go and check the second bit. If second bit is 0, it is class B. Hence, go to the third one. So you will see, if first bit is 0, is class A. But if it is 1, check second bit. If you check the second bit and it is 0, it is class B. But if it is 1, check the third bit. If you check the third bit and it is 0, it is class C. But if the third bit is not 0 and it's 1, check the fourth bit. If the fourth bit is 0, it is class D. But if the fourth bit is 1, then it is class E. So let's pick an example. For instance, let's take notes. If you can see my notes, let me know, please. I'm bringing up a notepad. Once you can see my notepad, please let me know. Can you see my screen now? Hello? Hello?
Yes, sir.
Yeah, can you see my screen?
Yes, sir.
So,
I can see it. I have to log in and log out.
okay, so I did 192. We want to check what class is 192.168.30.6. So, let's check the first number, which is 192. Let's convert 192 to binary. Remember, if we want to convert it to binary, we said we would 192, then we divide it by 2. Divided by 2. I'm looking for my division here. So, how many 2 can we see in 192? So, 2 goes in 19 should be 9.
9
Remainder
remainder
1.
1.
And in 12 will be 6.
96.
So, remainder 0. So, then we move on again. 2 goes in 96 now. In 9 will be 4. Remainder 1. In 16, it will be 8. Remainder 0. Then 2 goes in 48 will be 24. Remainder 0. 2 goes in 24 will be 12. Remainder 0. 2 goes in 12 will be 6. Remainder 0. 2 goes in 6 will be 3. Remainder 0. 2 goes in 3 will be 1. Remainder 1. Right? 2 goes in 1 will be 0. Remainder 1. We bring that one out. So we now write it up. So that will be 1 1. Then how many 0? 1 2 3 4 5 6. 1 2 3 4 5 6. That would be base 2. So this is 192 in base 2 in binary. So we said that if the first, let's go and check our diagram now. The picture. Are we still here? Can we see it?
Yes, sir.
Okay, so let's look at it now. The first bit here is 1. Abi, we said if the first bit is 0, is class A, but our first bit here is 1. So we move to the second bit. Are you seeing that? The second bit is 1 again. That means if it is 0, it will be class B, but it's still 1. So we go to the third bit. The third bit is what? Is 0 here now. So that means 192 is a class C IP address. Do we understand what we've done here?
Yes, sir.
Are you sure? Should we take another example?
Yes, sir.
Yes.
We should move forward, or we should do one more example.
So let's move forward.
Okay, let's
It's
move forward.
clear.
It's clear. Okay. So once you are able to convert it to binary, then check the first bit. Assuming we have something like 101111, that means it is class what?
Class Class B.
Thank you. I like that. So first one, we check the first one is not 0, is 1. So it's not class A. We go and check the second bit is 0, so it is class B. And then it follows that procedure. So when they give you an IP address, all you need to do is to try and convert it to binary. Once you convert it to binary, you will know what class it belongs to. But this technology or this formula only works for classful IP addressing. So we move on. So if the first bit is 0, it's a class A address and we are done. Have the okay, so that's just what that is saying. Class B, class C, and D. So classful IP addressing is an IP addressing method that divides the IP address space into 5 classes. We've explained this. This method was widely used in the early days of internet, but has since been largely replaced by classless inter-domain routing. That's what we call CDI. Due to its limitations in flexibility and efficient IP address allocation. However, it's the foundation of IP addressing and it is crucial to us, especially because of what we want to achieve. So we brought the summary down here. Class A, it ranges from 0.0.0.0 to 127.255.255.255. The default subnet mask, I've already explained this, 255.0.0.0. The network bit is 8 and the host bit is 24. Number of network is 128. That's 2 raised to power 7. How did we get that? So the network, this is the network we are talking about here. The network, but the network 127.0.0.0 is reserved for loopback testing. So when we say loopback, I'll give you an instance. So if I power up my command prompt and I just ping 127.0.0.1, it will respond whether I have the internet or not. This is a loopback. It's used for testing TCP IP suite. We call it loopback IP addressing. Okay, so host per network is 16,777,214. That's the number of hosts you can have. So if you have a very large network, that is what this is. Designed for very large network. Class B, it range from 128.0.0.0 to 191.255.255.255. The subnet mask is, you see, it's called default subnet mask. It can be changed. 255.255.0.0. The network bit is 16 and the host bit is also 16. And number of network 16,384 is 2 raised to power 14. Host per network 65,534. Same way. So we are seeing -2 here. This -2 is talking about the network and the broadcast IP. I will explain that in a jiffy. It's designed for medium-sized networks. Class C, that we are very familiar with, 192.0.0.0 to 223.255, 255, and 255, and the default subnet mask is 255.255.255.0. The network bit 24, host bit 8, and then the number of network 2,097,152, and then host per network in a network is 254. You see there is -2, designed for small network. Class D 224, it's for reserved for multicast groups, and this is reserved for experimental. That's class E. So address structure. We've actually looked at all of this. Each class has a different structure defined by the number of bits used for the network and host portion of the address. Class A, the network is 8-bit, the host is 24-bit. Example 10.0.0.1. Network here is 10, while the host is 0.0.1. Okay. Class B, network is 16, host is also 16. So 172.16.0.1. So the network here is 172.16 and the host is 0.1. Class C, network and host. The network is 24 bits, the host is 8 bits. 192.168.0.1, the network 192.168.0 and the host is 1. So there is special IP address. What do we call special IP addresses? Certain IP addresses within these classes are reserved for special purpose. Number one is the network address. The first address in any subnet used to identify the subnet itself is what we call the network address. The first. So for instance, this IP, for instance, this IP now, 192.168.16.0 is the network. 16.0, 172.16.0.0, that's the network. And the last IP, which will be 172.16.255.255. This will be the broadcast. That's the last IP. That will be the broadcast. So the broadcast, the last IP, the last address in any subnet used for broadcasting to all devices in the subnet. So that last IP is the one they used to talk to everybody. Hello, are you there? Hello, are you there? So these two addresses, they are always reserved. That's why you will see that when we're talking there, they were using -2, -2. This -2 is talking about the network and the broadcast IP. The network and the broadcast. Then we have loopback IP. I explained this and I ping it to us. It's used to refer to the host itself talking to yourself. Hello, Mayokun, are you there? Hello, Shegun, are you there? That's what that loopback IP is used for. Then private IP addresses. Specific range in each class are reserved for private use and are not routable on the internet. E.g., 10.0.0.0/8, 172.16.0.0/12. So these major ones cannot be routed on the internet. We call them private IP address. Limitations of classful addressing. Why is it? Just give me a moment, please. All right.
I need new translation verse of what is Second Peter chapter 1 verse 3.
Drop it on my WhatsApp.
Like, can you copy and send
I'm
it?
almost done in this class.
Solution you gbọ́dọ̀ tó ti gbọ́.
So what are the limitations of classful addressing? Inefficient use of address space. You see that you can waste so many IP addresses because you cannot subnet. You cannot do it to, maybe you just need 10 IP addresses. Then you have to go for maybe class C and you are going to waste 240 IP addresses. Inefficient use of class address space. Large portions of the address space can be wasted because the fees network and host sizes don't always match the need of the organization. Lack of flexibility. The rigid class structure does not allow for flexible allocation of IP addresses, leading to potential shortage or over allocation. Subnetting constraints. You can't do any further subnetting. It's already there by default. So you just have to use it. Conclusion: classful IP addressing was an initial method used to allocate IP addresses, but has been largely replaced by CDI. When we see the CDI, we said it is called classless interdomain routing due to its inefficiency and inflexibility. Understanding classful addressing is important for historical context and for certain legacy systems, but modern networks predominantly use classless addressing techniques. Thank you. Any question? Any question?
No, sir.
All right. If there's no question, thank you for coming to class. Do have a wonderful night.